The moons of Saturn are numerous and diverse, ranging from tiny moonlets only tens of meters across to the enormous Titan, which is larger than the planet Mercury. There are 146 moons with confirmed orbits, the most of any planet in the solar system. Enceladus is the sixth largest moon of Saturn. Enceladus is considered one of the most promising places to search for alien life. Now scientists have detected the last of six necessary ingredients, that is phosphorus, the rarest element critical to life as we know it. Phosphorus has for the first time been discovered in an ocean beyond Earth, spewed out from Saturn's icy moon Enceladus. The vital element helps make soil fertile on Earth, and researchers suggest concentrations of phosphorus may be at least 100 times greater in the hidden seas of Enceladus than in Earth's oceans. The new findings also suggest the waters of other icy worlds may be similarly loaded with phosphorus, such as Jupiter's fourth biggest moon, Europa, and Saturn's largest moon, Titan. Phosphates, or compounds containing phosphorus, are essential to key components of life on Earth, such as DNA, RNA, and cell membranes. Of the six elements required for life, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is by far the least common in the universe. Phosphorus was the only one of these six key building blocks that astronomers had not yet detected in material from Enceladus, although the detection of sulfur is still considered tentative. Starting in 2004, the Cassini spacecraft flew into dust from the second outermost ring of Saturn, the E ring, which is composed of ice grains ejected from Enceladus. Now scientists studying the ice grains measured by Cassini's cosmic dust analyzer have detected the elusive element phosphorus, detailed in a new study in the Nature journal. The sixth largest of Saturn's moons, Enceladus is only about 314 miles wide, making it small enough to fit inside the borders of Arizona. When the Cassini spacecraft first arrived at Saturn in 2004, scientists expected Enceladus to be a frozen ice ball. But the next year they detected plumes of water vapor and icy particles erupting from geysers on the surface, revealing the existence of a global ocean between the moon's icy shell and its rocky core. Scientists previously found that Enceladus's ocean might also contain complex organic molecules. This makes Enceladus the most promising place, the lowest hanging fruit in our solar system to search for extraterrestrial life. Until now, no one had detected phosphorus from the ice of Enceladus or similar worlds, calling into question whether these places could truly be habitable. People were really having doubts as to whether or not phosphorus might be the bottleneck for the possibility of the emergence of life. Previous models of Enceladus and other icy ocean worlds were divided on whether these hidden seas possess significant amounts of phosphates dissolved within them. Phosphates don't like to dissolve in water, so it's in principle harder to find in oceans. Early research suggested phosphates may be trapped within the rocky cores of these worlds. However, more recent work hinted that phosphates could also be abundant in the oceans. Of 345 ice grains from Saturn's E ring that Cassini examined between 2004 to 2008, the scientists detected 9 grains with phosphates. The most surprising thing was how clear and unmistakable the phosphate signatures are in the data. It took years analyzing a lot of data, but from scientists' perspective, this is really a bulletproof detection. Recent work controversially suggested the detection of phosphine, a compound of phosphorus and hydrogen, in the clouds of Venus. However, when it comes to Enceladus, there is no controversy here. Phosphate and phosphine are different. On Enceladus, phosphates, which are compounds of phosphorus and oxygen, do not require any exotic reactions, while phosphine in Venus is much more challenging to explain. based on phosphate levels seen across the icy grains. The scientists estimated phosphorus concentrations were 100 to 1000 times greater in Enceladus's waters than Earth's oceans. Lab experiments conducted by scientists suggested this was possible because Enceladus's ocean is, like soda, rich in dissolved carbonates. This soda ocean can dissolve the phosphates in Enceladus's rocks. In addition, the waters of icy ocean worlds in the outer solar system, such as Pluto and Neptune's largest moon Triton, should also be replete with carbonates, suggesting they may also dissolve phosphates from rock. NASA's planned Europa Clipper mission, scheduled to launch in 2024, may detect phosphates in icy grains spewed from that moon. Though the detection of phosphates on Enceladus raises exciting possibilities, the small number of ice grains that the researchers examined leaves some unanswered questions. Future research is needed to determine whether these phosphates are truly found everywhere within Enceladus's ocean or in just a few spots. The next step is to go back to Enceladus and search with suitable tools for organic biomarkers. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.